So looking at number 9 on page 8, we have find the arc length created by the overlap between r equals 8 cosine of theta. So I'm just going to kind of get a little sneaky here, just so I don't have to type the word theta again. 8 cosine of theta. In terms of an interval, well, I don't know how much of it I need, so let me just leave it as is for a second. I have that pi over 4 as a holdover from the last problem. Let me type in r equals 4. All right, so if I want some overlap, I'm probably going to need a little bit more area here, or at least more arc. So, oh, I tried doing that before. So let me do, well, 2 pi. I can just do pi if I want. Because we learned, I believe, a couple of pages ago that when you're dealing with a circle of this variety in the form of a cosine theta or a sine theta, that the domain tends to be 0 to pi. All right, so we're looking for the arc length created by the overlap. All right, so what I'll do is I'll get a little snip, crop this bad boy, a little bit more cropping. I'm not going to keep that one. Just pop it in right here. And I'm just gonna snag that. Just put it right on top. All right, that other graph is just if you wanted to actually draw it by hand. All right, so let's get a little thicker. Here's the overlap. This one and this one. So it looks like if we really kind of break this down appropriately, it looks like we're dealing with 4 congruent pieces. So based off of symmetry, if I could just figure out one of them, then I'll have what I need. All right? So because we're looking at 2 congruent circles, both of them have a radius of 4. How do I know that? Well, this has a diameter. Oh, no, that's too thick. This is a diameter. All right? And the spacing is such that the radii are equivalent to one another. So the radii get you from center to center. All right. So if I could just figure out that one piece, then I'll be in pretty good shape. All right. So I can actually kind of get rid of all of this stuff, at least for the time being, and just focus on that. All right. So what I would do here is, so it's like work harder, work smarter, right? So I just need to figure out that one piece of the circumference. So that's this guy. So I'm going to need a domain to work off of. So I need my angles. All right. So let's focus on that for a second. 8 cosine of theta is going to be equal to 4. That'll get me the intersection right here. All right, so 8 cosine of theta is equal to 4. So that means cosine of theta is equal to 1/2. 4 over 8 is 1/2, making theta equal, first quadrant. It's a first quadrant measure, so we're looking at pi over 3. All right, so we got that part. And we can verify it, just focusing on the 8 cosine of theta. Just pop in a pi over 3 and see where that gets you. That gets you to the intersection, so we know we're in good shape there, all right, location-wise. As far as the circle, r equals 4, well, we know that starts at 0 and ends at 2 pi, so I want to go, that we know from experience at this point. So my arc length, S, poor quality S, is going to be equal to the integral over the interval of 0 to pi over 3. Let me just smidge this over, actually, of 3 squared, oh, sorry, it's right in front of me, 4 squared, r prime is going to be equal to 0, all right, so plus 0 squared, d theta. This tendency to write the wrong thing, unfortunately. Simplify, we're looking at 4 d theta, which gives me 4 theta over the interval of 0 to pi over 3, which would give me 4 pi over 3. All right, that's just that one piece. All right, so if now I want to bring back the other pieces, so this one, and this one, and also this one, what I would then do is multiply that result by 4 and get 16 pi over 3.